Okay.
Did you guys hear that?
Yep, we are being recorded.
Okay, so Nick,
All right.
take it away.
Ooh,
And yeah, let me know if you guys can read this. Okay. Um. So yeah, welcome everybody. Thanks for having me. I think I've been showing off or showing up on and off, mostly off. I think, but and this is a topic I've kind of like talked to Greg about for a little while, and I was uh, actually like the very first day of like when the talks finally when the meetups started happening all over again. I mentioned this, and it's just been brewing, I guess, in the back of my mind. And when the the meetup happened about kind of discussing the future of this, I was like, okay, I think it might be time. So, well, yeah, welcome everybody, and we're viewable worldwide now. So,
great.
um, okay, so a little bit about me. I'm Nic Flores. I work for at Northern Trust. I'm a backend software engineer. Uh, although I feel like most of what I do is, uh, you know, terraforming stuff. Then I get to write just a little bit of code, and then somebody else kind of takes over. I write mostly in Rust, but I can do other things, and I'm certainly very Haskell curious. And this has certainly been an enlightening uh, month, just trying to get this project up and running. And so I did learn quite a bit, and I'm happy to finally share. Actually, hold on a second. There should be a break in here. I wrote this about me slide like a minute ago. Um, okay, here we go.
I have a quick question, Nick. Are
Yeah,
you using a Patate because like do you usually use it, or are you using it specifically because you're doing Haskell stuff and so you wanted to use a Haskell? Um,
I yeah. I mean, is it potato or patat? I don't know.
some say
I
potato,
said
some say potato. I don't know.
I wanted something like just easy to do, and I wanted to include it within, like, I want to include the slides within the source code,
Ah, that's
you
cool. Yeah.
know. And so I spent like, a couple of days kind of looking into it, and I actually kind of like it. It's kind of slick, it's very minimal. And so yeah, I kind of like it.
Cool.
Um, I will probably use more of it as I do more presentations, hopefully. So what we're going to do is we'll build a very simple financial data downloader. This sounds very fancy, but all we're going to do is make a request to Yahoo Finance and write the data to S3. Um, and believe it or not, like I feel that a lot of first of all, we do a lot of this at work in one way or another, and so I thought like, hey, why not do this in Haskell? I don't have the opportunity to do this in Haskell at work. I could do it in Haskell for this meetup, and hopefully coworkers would show up and see this. But no,
They watch the video and force them.
yeah. And so along the way, we'll get to look at some library choices I made. Um, and we'll be writing some web requests, which I thought in Haskell, or at least, would be intimidating. And they weren't too bad. So we'll get to see a little bit of that. Learn how to interact with AWS. This too, I thought would be complicated, but it wasn't. At least uh, not in the way I did it. Um, and then we'll look at like how I did my application configuration, and then we'll do a very quick demo of this code running in AWS.
Very cool.
So uh, before actually the before you showed up, Greg, and we were talking about like whether or not I used any Copilot or something to while writing this. Um, I didn't, but it actually turned out really useful to like summarize things. And so I didn't know really, other than like, searching on Hackage for Haskell libraries. Um, but I don't have like, the knowledge that I do about like which libraries to reach for, like I do, for example, in Rust.
Yeah.
And so that's when that came really handy, because you could tell it, hey, give me a list of 5 libraries that do blah in, that have been published and that have been updated in the last year. And so that was really useful. And so that landed me on Yasad first, which turned out to be a very comprehensive web framework. Um, it seems a full featured kind of like all batteries included framework for strongly typed uh, 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 web development. It kind of has its own templating system if you're doing like HTML generated HTML. It can do form handling, authentication, and persistence layer uh, stuff. So, but I did feel like this was a little too much for what I kind of wanted to do. Also, like Snoiberg is behind this, and he's like also just a Haskell wizard. So um, I might go back and kick the tires on your side. Um, there's also Servant. I know that Greg and Robert use this. It expects a full like type description of your web APIs, and it's a little um, it was a little unfamiliar, right? So essentially what my evaluation for these libraries were like, can I look at the code and know like kind of exactly what's happening? That was kind of my evaluation of them. And it did take me a little bit, right? If I couldn't look at it and glance at it and realize like whether or not, figure out what was happening, I kind of skipped them.
Mhm.
And that's when I landed on Scotty, right? Scotty was super lightweight. That's what I ended up choosing. And, it, it has this like, they say that's like Sinatra inspired. I don't know what that really, that doesn't really mean much to me because I've never really used Sinatra, right? But, um, um, when I looked at the essentially the definition of the server and the handlers, like it was like very familiar, like it was almost Rust like in a way.
Cool. Yeah.
If I can just
Yeah.
comment. So, like, you think about why we're using Haskell, right? It would be cool if you had type safety in your HTTP, right? You cannot have broken links, right? You're
Yeah.
supposed to have a REST API, and the post has this JSON payload. but you're keeping it a different JSON payload. Well,
Yeah.
this is the basic type safety issues associated with making web API.
Yeah.
Out of these
So
three choices, only one of them really gives you that, and that's
yeah. Yeah. So that's certainly true, right? Scotty does give up,
Hmm.
right, a little bit of the type safety that you get
Well,
probably with
Scotty
Servant and stuff.
is really a server, is not a client, and servant is both server and a client. So by creating these types, you have to implement them correctly because otherwise things will compile. And when you call them, you have to call them correctly when you make the call from Haskell to Haskell, right?
Yeah, yeah.
So that you basically have this guarantee of like things ain't broken in the
Hmm.
in the RESTful HTTP conversation.
Yeah.
Just want to interject, but I think I agree with you. If I would like first experiment with it, I probably would still go for something like Scotty because you want to see more like how things are done as opposed to
Hmm.
right. Yeah.
Yeah, I certainly, so like what I had in mind was like I want to just run a curl request against my API, right? Like
Yeah.
I hadn't thought, further down the line, and I kind of addressed this later on as to like, like kind of what else could we talk about if we decided to do a follow up on this topic, right? Um, um, I also, you know, I kind of used Will Kurt's book as a guide, right? Getting programming with Haskell by Will Kurt, as a guide to some of this, and like towards the end, right? Like so I kind of like structure. I figured like what I wanted to do is structure the talk is like this could be something that somebody could pick up after reading that book and do a little bit further of a project, right? Because like some of the HTTP stuff that he talks about at the very end, of the book is very short. And
Mhm.
so not, it's not very elaborate. Uh, and so I figured like you finish that book and then maybe you find this talk and you get to see uh, how you could extend a lot of what Kurt sort of explains throughout the book and later on at the end of the in the web section at the end of the book. Um, and so yeah, I was looking for simplicity most than anything, and I wasn't yet thinking about like, okay, am I building a distributed system where two servers need to talk to each other? Maybe not quite yet. I wanted just to run curl commands against my service just to make sure that it does what I needed to do, and I would be good for right now. Um, so using Scotty. So this is this is an example um, of, of a short Scotty server, right? Or a very minimalistic um, sort of web server that you can write with Scotty, right? And so I've been intrigued by this kind of this idea, right, of like being able to write your own servers for a long time. I you know I used to deploy web servers onto Tomcat, right, or Apache,
Yeah.
and stuff like that. And like when I finally learned that like there were libraries and people were creating libraries to sort of write your own, I've been very intrigued since then, and these things have kind of fascinated me. And so it's just being in control of the web server yourself is kind of nice. I feel it's kind of nice. Um, and so right, I glanced at this, and then, it's, I think this is probably on their website, uh, and it was clear what was happening. Right, it's also very minimal. Like, this is
Yeah.
like the smallest server that you could probably write. But granted, there's like three more lines that you probably need, but like the imports and the overloaded strings um, um, directive that you need to add. But like, getting something like this started in like Rust is, there's quite a bit of work you still need to do, right? Like, it's not as straightforward. Granted, I think Rust is a little less than Scala still is a little more pomp and circumstance that you kind of need to go through to get a very minimal server up and running, assuming you're using something like um, HTTP4S or something like that. um, so, so just kind of very quickly here, like, obviously here, this will start, the server on port 8080. Um, and the signature of Scotty is, you give it a port and a Scotty M, and then you'll get an IO. And obviously here, can you guys see if I highlight?
Yep.
Okay, cool. So obviously here's the ports, right? And so this the rest of this must be, right, like the Scotty M. Um, and so this kind of just made sense. I was like, okay, I can work with this. Also, a lot of this it was very reminiscent of how of the Rust Actix, is it Actix or Oxum, actually, framework that we use at work for writing servers. So I knew exactly what was happening. Um, right, and this defines a handler, right? A handler or an endpoint. I kind of go back and forth with that, with those two words. Um, um, so bear with me as I go through the talk. Um, and in this case, get is a route pattern and an action M, and right, we expect the Scotty M because the Scotty M or Scotty here, or the Scotty function requires the Scotty M um, input in the second parameter there. And that's it, right? Like, that's how we're going to get started with our task of writing a file downloader. So we'll be writing two handlers, right? One is going to be a health endpoint, since we're going to be deploying this code to AWS, onto an ECS cluster, right? Ideally, the cluster is going to want to interrogate your service to make sure it's healthy, and so you get some feedback in your metrics of ECS or whatever. And so we'll write one of those, and then we're going to write a post endpoint for to instruct our server to download a specific or some data about a specific ticker from Yahoo Finance, and and this function is going to write it to S3. Now, so the way I solve this problem is might not be the best, but I'm open to feedback and in general heckling if you want or whatever. Okay. So the Scotty handler is pretty straightforward. We're gonna call it health check, right? And it should return a Scotty M like we just saw earlier. And the health endpoint is just /health, And the only thing is now what should our our action M be? And simply we're just going to return a 200 always, and it'll be a little bit of JSON just saying that the health is okay, right? And here we'll define a health new type, and with all the things that all the ASON things that it needs in order to render correctly. Here we use new type and not data because it's a single parameter. I kept wanting to write data because all the examples I saw, like there were sort of larger objects, I guess, that they were writing or outputting, and so a lot of those came with like uh, those were data objects, I guess, or as opposed to a new type. And so this caught me off guard, and I learned that you use new type when you only have a single field. Okay, so that's the first handler that we needed to write. We're done with that, and of course the meat of this problem is the downloader. So this is going to be a post. So and we're going to call it download ticker data. Right?
Nic, sorry to interrupt.
Yeah.
I was looking for a place to raise my hand, but I haven't used Zoom in a while.
Yeah. Feel free to interrupt.
What do you have a specific JSON? It's a little unfamiliar territory for me. Do you have a specific JSON library that you were using?
Oh, ASON.
ASON.
Or ESON, right?
Okay.
Yeah. That's
Is that a standard?
Yeah.
Okay.
Yeah.
It's pretty dominant in the Haskell world. Yeah.
Okay. I think. Yeah. Okay. Thank you.
You're welcome.
So the next to share button in the bottom, like the green one, there's a React, and React has raise hand as a button, and emojis otherwise. So I just do an emoji.
Cool.
Gotcha. Thank you. I see it now.
Oh yeah.
And then here, so we're calling it download ticker data, and it's gonna take in a app config parameter. Later on, I'll talk about the application configuration. For now, I'm just going to kind of just use it as I need it. Right? I'm going to assume it's there and just use it. So for the first part of this, also very straightforward, right? You write post and the string that matches your URL that you want to have. Then the first thing is that you want to extract the ticker parameter, and you just simply use path param to get the ticker out of your URL path. And then now this is very crude validation, but I wanted to have just to show just a little bit of validation here. Like, right, I don't want a null ticker and I don't want something very big. I should probably also just check that maybe they're all, that it's just letters and not numbers or special characters. But for now, like, this is maybe enough. Ideally, right, you would use a better validation framework or something that is useful. Sorry, my cat's hungry. No. So right. So then here, supposing that things didn't work, you would return 400 for a bad path parameter. But if things did work, you got past your validation, uh, in this area, it's probably where the meat of your work is going to happen, right? And then you can then assume like, well, suppose the meat of my work happened, what should this be? Well, I kind of told myself, well, I want it to kind of be an either, right? And if it's an either, then I want to just handle the two cases, right? Well, if there's an error in the either case, then I'll just return whatever that error is, And if everything's okay, I'm just going to return a 200. Okay. And so really now we come down to like, okay, well, what should really go in here? Well, I said it should be like an either of a something or something, right? So it should be the either of an X or a Y. But right, you're in this, you're probably, uh, I said we're going to go download something, right? So you're going to do some IO. You're going to go do an effect. So it should probably really be an IO, right? But uh, but you're not quite in an IO because you're in this do clause, right? And so you can't really tell here, but like what's really nice, I figured out in your IDE, you can just hover over your do and it'll tell you like what kind of context you're in. And so you'll notice that it's not an IO, right? So you're in an action T. Action T being, something Scotty related. And so really what needs to
And
happen then is you need to lift your IO into that action T. Yeah, go ahead.
I was just going to say, so the action M is like an action T ID or
Uh,
identity. Is that right?
um, you mean it's a type synonym? Is that?
Yeah.
Yeah,
Is
yeah,
is it? I assume it is, but I'm not
yeah, yeah,
sure. Cool.
So I just looked up Scotty M. It's
yeah,
basically it's a reader and state transformer. The reader is for the way for the ways for the wrap stuff, the Y stuff, and
yeah.
state is for Scotty state. I don't know how that is being used, but action I don't know it. Yeah. Mm. So they are basically um, transformers.
Right.
Typically reader and state, I think. Let's see.
So at this point, you notice that, or um, that the right hand side of this dollar sign is probably what you really need to determine what it's going to look like. So you can see here that like, well, you could write a function called copy data to S3, right? And if you give it the ticker, which you extracted from the path parameter, and if you give it the config, right? The config because, well, it probably has some information about like which bucket to write it to, right? Maybe you want to store like the Yahoo finance URL in that config, and maybe other things, like maybe the key, like the path of where you want the file to go, right? So all of that can be used by this copy data to S3. And so that's what the handler maybe would eventually look like,
Mhm.
right? And so now the task is like, let's write our copy data to S3.
So Nick, I'm curious, did you actually go about like writing things in this order? Like say, like kind of put in placeholders or whatever, kind of the way you did, and like also the same copy data is like basically does nothing, just returns like pure or IO, whatever, and or did you go about it a different order when you were actually
I
coming up with it?
I that's an excellent question because I went about it in a different order, right? My first plan of attack was like, can I just reach Yahoo Finance,
Mhm.
right? Um, uh, right. When I came to writing the slides, I wanted to present it in a way that like was more, I guess, methodical in terms of like, let's see what the server looks like. Let's see what the handler for the health looks like. So it's incrementally, I guess, more complicated as we go along in the slides, maybe. Not really more complicated. It's just more to handle as we proceed.
Yeah. No,
Right.
I think this makes sense. But I write code, maybe not quite the same way you do, but like I'm like, I would find myself like working on the HTTP stuff in one place and like in another file, like working on like the S3 stuff, and like eventually like, oh, all these pieces are going to connect eventually. But I don't feel
Yeah.
like, I was just curious if you have if
Yeah.
this actually reflects your process, because it would not reflect mine. But it makes sense for the presentation, of course.
Yeah.
So,
Yeah.
anyway.
Yeah. No. For sure. It's. Uh, I mean, initially, my first pass at this copy data to S3 was essentially the download ticker data,
Oh,
right? So
okay.
it was
Mhm.
one giant function, right? That I
Right.
realized, like, okay, I have this working, which is my first pass at this. How do I tease this apart and make it, presentable, first of all, and then make it so that, like, uh, uh, it's not, one giant function, you know? Um, so, okay. So here we go. Uh, in order to so at this point, right, like we know that now copy data to S3 needs to do things with reaching out to Yahoo Finance, and also needs to do things with AWS S3. So, back to the drawing board about like which HTTP clients could I use. And so here we had uh, HTTP client, which is uh, a library, uh, uh, and it's, I think Storybrooke is also behind this. It seems to be super minimal, low level. Uh, with And then there's another add-on to HTTP client actually called HTTP conduit, and so kind of helps you kind of deal with like uh, to not do a lot of the minutia that's kind of behind the HTTP client. It kind of handles that for you. Um, so it's written at a slightly higher level, right? There's also rec. I kind of looked at it. It looks interesting, but it hasn't been updated in quite a while. So I kind of just decided let's give HTTP conduit a try. Um,
Well,
and so,
there is one more, and this is the one I would use.
uh-huh. What is
Servant
it?
cli- servant
Servant.
client.
Yeah.
Oh yeah, servant.
Servant client. I would just write type, which
Mm,
represents whoever I'm calling, which is
mm,
Yahoo, right? And it would write all the code for me. And I
uh,
would just do, I would just run it. Yeah. So this is what we do because we talk to Python microservices quite a bit.
uh-huh.
So Haskell, when it still was developed actively, when talking to Python, Python services, would have an API defined in Servant for all the other language
Yeah,
microservices. And we just make the calls. Like if it was Haskell. Yeah.
nice. Yeah, like I said, I'm gonna have to go back to that. Okay, so using conduit. Here's another example of how to just make a very straightforward, sort of simple HTTP call with servant. Sorry, with conduit. Um, and so you can see here a couple of things that I want to point out is that you know you write your URL as a string, and then you call parse request on it. And then you use HTTP LBS to actually execute the request, right? Then you get your response, and then you can do things with your response, like you can call, get response status code on it, right? And this would return the status code of the response that you got for making the request. So we'll be using these two functions at least, this parse request and this HTTP LBS, as we build out our request to Yahoo Finance. So again, I saw this and I was like, okay, this is very straightforward. I understand what's happening here. I can imagine what my request looks like in terms of this really simple example. So I'm just going to talk about the Yahoo Finance really quick, just because I want as a guide to what we're going to build. So requesting data by a ticker to Yahoo Finance is like you have to use this URL, and this is the URI that you need to use. You attach your ticker right here, so you can say like AAPL, and that would make that request to download the AAPL data. I figured out that I needed these two headers, right? Otherwise, it wouldn't work for some reason. So we need those two headers. And then we can pass in query parameters. There's range, interval, include pre-post and events. These won't be too. We're not going to use them too much or at all actually in the rest of the talk. I wanted to have some kind of query parameters in there just so that we show how to build a more slightly, complicated request, right? So this is the curl command that I started with. And so this is the curl request that we want to turn into some code. And I wanted to touch in as many aspects of like building the request as possible, right? So headers and query parameters are usually the most common things.
And Nic, how did you discover that those headers were needed? Like, I mean, did you struggle? I mean, was it a struggle to like get that figured out, or
Yeah, just trial and error, lots of Googling, seeing various examples, like some people doing something, some people doing others, and then kind of meshing the two together. So it was a lot of trial and error.
So you're lying a little bit, right? Because user agent Mozilla 5.0.
What's that?
This is a little bit of a lie, right? User agent
Yeah.
Mozilla 5.0.
But everything I feel like needs a Mozilla user agent. Like I definitely have modified some of my like I have a Chromium thing that runs a bunch of like chat apps and stuff like that. So I don't have like tons of different apps for chat stuff, and I've had to like change the the settings in that for a couple services to say that it's Mozilla. It's just like, okay, now it works even though it's Chromium. It's just like whatever.
Yeah. Why do you say it's a lie a little bit, Robert?
Because Mozilla 5.0, your web.
Yes.
Right?
Yeah, you're like claiming to be Firefox.
You're pretending to be a Firefox, right?
Yes, I am lying to the server for sure when I send this request.
Right.
But it wants me to lie to it.
You're right.
Okay, so so just kind of stubbing in some things here. This is just going to be this is just going to build for us, right? Given the ticker and the config, it'll build for us the request, right? So we're going to need this function later on, and I thought it was kind of neat, so I wanted to present it as well. So if you notice, right, we're going to extract the base URL from the config. We're going to like add this / and then add the ticker. right? And then I don't want to clutter this too much, but we'll have the query parameters and the headers in here, right? And then we're gonna build the request with this command here. And this line, took me a little bit of time to kind of parse. It didn't look like this originally. Okay. So this wasn't something that just like fell out and like I said, oh, I can easily write this line, right? This took several iterations. There were many more dollar signs and many more lets and so on, right, to sort of build this. But what we can see is what's happening essentially here is that uh, uh, well, let's just look at first the operators that are in this line. The dot is just function composition, right? So we're f dot g here is just saying perform g first and then apply f to it. So that's kind of what's happening here, right? This would be your f, and this would be your g. And your bracket dollar sign, right, is you're mapping a function over a functor, right, um, or uh, uh, you're mapping a function over uh, a context that has some stuff in it. And even knowing this took me a little bit of time to realize what this was happening, right? So what kind of finally clicked is that, okay, well, if this dot is function composition, right, the result here is just a function, right? And it took a second to realize, oh, well, parse request, well, that returns to me an IO of something, right? And that's when it clicked, right? So that's when I realized, oh, like this is the operator that I need here to apply this function to the thing that's in here, right? Um, and so that's how we get this IO of a request result out of this function. So yes, this might be straightforward for a lot of folks. I wanted to make sure to like in these operators, right? Like are things that Will Kurt sort of mentions, right? Uh, he progresses through the book, kind of explaining these parameters and explaining the concepts behind these not parameters operators, explaining the concept of these operators throughout the book, right? And he'll uh, and then at the very end says, okay, well, now that you know all of this, you don't really have to think about it because do and bracket dollar sign kind of do a lot of the lifting for you. And this is kind of maybe a small little example of a lot of what Cart kind of goes through.
So I have a question for you.
Yeah.
Were you developing this? Did you use like HLint or like language server?
Yes, I used what's it called? GHC GHCID. Yes. Is that what you mean?
Uh, no,
What IDE are you
probably not.
using?
Yeah.
Or are you using
Oh, I was
Visual
using
Studio or
Visual Studio Code.
Visual Code? Yeah, VS
Yeah,
Code.
so
And
there's an extension for Haskell, like a big one, and
yeah,
for Visual Studio Code. And
Yeah, I do have one of those installed. Let's see.
and that comes with HLint. And HLint, when you start typing like lots of dollar signs and stuff like this, it's going to suggest to you simplification of that
Oh,
statement. So if you start with something very verbose, it will probably start suggesting, hey, go and change that, remove the lambdas, and apply. Um,
okay.
um, that's actually pretty good in doing this. So I just wanted to mention because okay, you said that you struggle to get this final line,
Yeah.
and HLint quite often helps
Mhm.
in
Hmm.
narrowing that. It's pretty good in like sensing that the code can be improved. Um, um, it's mostly all work with one-liners though. So if you had split in several lines, it may have not noticed that.
Yeah.
But if you have one liner which was optimizable, it would sort of make it look nicer.
Yeah.
But
I
Nick, that's
mm,
totally like your final thing there is definitely like that's how I would write that code.
Yeah.
Like you got to like I feel like the end point.
Um,
yeah,
okay.
sorry for interjecting, but I thought
No worries. Thank you.
this lint is
Um,
pretty powerful, like in my experience.
let me just catch up here. Okay. Um, okay. So here's our two. Here's our. So if you filled in the rest of this code, right? Like, I just filled in the query parameters and the headers. Um, um, Again, you might want to grab these out of the config or something. For now, I'm just putting them in there because they're not going to really change, at least for what we're doing.
You have the names backward on those too. Just
Oh,
query
do I?
params for the headers and headers for the query params.
Oh, shoot. Sorry.
And I was
Let
just going to
me.
ask the just there, like if it's nothing, it just means there's no equal sign. It's just like a valueless parameter or whatever, I guess.
Oh, yeah. Let me. While you're saying that, let me just fix that because I'll forget. I didn't even notice. Okay. Um. Okay. So we know how to make requests to third-party APIs. We're going to look at AWS libraries now. Um, this was also just a choice as to like how did I understand it kind of like by just glancing at what was happening in some of the examples for each library. Um, did it? Uh, could I understand it immediately? And then, so actually, I need to fix this because this is not quite correct. Um,
What do you mean by minimal resources? Like it doesn't support a lot of the AWS services, or
well, I thought initially, but then I looked at it again recently, and I was like, oh no, it sort of does. It seems to be, from what I could tell, at least initially. Um, 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 Here, let me just talk about it and leave it alone. Um, uh, it seemed to like support like, or at least like looking at it in Hackage here. You guys can't see my browser. Um, um, it seemed to like be mostly for like like DynamoDB, uh, sort of like some of the bigger name like um, uh, sort of services that AWS seems to supports or has. And uh, so that's kind of what I meant. So this might be a fib. Sorry. No offense, AWS. I'm sure it's a great library. But the reality was is that when I looked at the code for this, or when or even it wasn't as straightforward to me as it was looking at the Amazonka examples. Also, Amazonka has the ability for, or it's generated from the AWS APIs, and it's very modular, so you can just import the parts that you want. So if you only want to interact with S3, you import Amazonka-S3. Although I think AWS has that ability too. But that's what I went with. And we'll see here an example of that.
Cool.
Yeah, and so for example, you can import Amazonka S3 or Amazonka SDS or and so on.
Okay. Yep.
And so how do you use it? It's here's a really simple example is that all you have to do is call new NV discover, right? And so I've seen this before in other code bases. Like I think Rust has something similar, where discover is going to run down a set of possibilities of trying to find credentials, like within the environment that this service is running in, to figure out how it can connect to AWS, right? So as long as you've supplied those things, right, like you more than likely you're going to get a connection. So it supports environment variables. So if you happen to export, your AWS credentials in your in your uh, terminal or something, and you run new NV discover, right? Like it's going to find those credentials, and then you'll have a connection, right? There's also config files, right? So if you have a .aws in your home directory with a credentials file inside of that, then it's probably going to find that, right? There's also like web identity and uh, um, uh, another situation, right, and this is another thing I use for this project is when you deploy, right? So if you use the AWS's Linux container, right? Um, when you deploy, it could find a AWS puts something in that container so that when it actually runs in their environment, right, it's able to discover a connection to resources within the runtime of the container. And so here, for example, once you get your env here, um, you can do a run resource T, right, which comes from Amazonka, and then you do just send. So you send, and you along with the send, you send your env, and then whatever else you want to do, right? In this case, I want to get the get caller identity, right? And so um, so you can imagine what we need to do here when we write a file, right? Instead of sending a new get caller identity, we send a put object, right? And so that if we can formulate a put object and pass it in right here, this would perform the writing of the object onto S3. Okay, well, let's see what writing into S3 looks like. So this is so this function takes a few parameters, and if we specify like a bucket name and an object key, which is the path of the file, right, and a byte string, this would ideally, right, do the writing of the byte string to S3. So the first thing we have to do is formulate this put object, and the put object is really like all the things you would expect to be able to write to an S3 bucket, right? You'd want the name of the bucket, you'd want like the path where you want the file to go, and then like the actual data that you want to write. That was pretty straightforward. And so once you do that, just like in our previous example, you do the run resource T and call send, and you pass in the environment. In this case, right, env here was passed into us, and then you instead of getting the caller identity, you're going to pass in the put request, and ideally this would write your data to S3, and then you simply just handle the a possible error in the upload result. Okay, so we'll take a little break. At this point, we've done a lot. I feel like we've written some handlers, or at least mostly. We've learned how to make HTTP requests, right? We've learned how to write a file to S3. Along the way, learned how to use how to authenticate to Amazon. Like we just need to assemble our copy to S3, or copy data to S3 function, right? So here we go. Our copy. I think that I might have. Did I misname this? I might have misnamed this. This should be copy data to your.
Oh.
Copy data to S3. Sorry about that. And actually, so sorry about that typo. It might get corrected as I move the slides forward. But here we have these three parameters: dependencies, ticker, and app config. App config we've kind of seen before, and I said we would maybe talk about it a little later. Right, ticker we've seen. Dependencies we haven't seen. That's something new. You can just kind of think of dependencies as the thing we're going to grab functions out of to use, right? That we've written already. So first of all, I'm gonna make a object here called fetch config, and this is just going to contain a base URL, right? The range and the intervals. This is kind of like the things that we need to make a request, and I'll formulate one of those. And then we've seen previously, right, the build Yahoo request function, right? And we just built the fetch config. So if we pass that and the ticker to it, it's going to build the request for us, right? And then the dep fetch data, right? We're just going to go into our dependencies and grab the thing that fetches data, the function that fetches data. right? And we've seen one of these before. If you just pass it a request, right, it should just give you the. It's just going to execute it, right, and run the request that you previously built and get you back a response. Once you have that, well, you'll handle the fetch result, right? If you handle the fetch result, well, if you get an error, we're gonna just return the error, um, and um, and if the fetch result has a body, um, we're going to grab the um, the environment, the Amazon environment from or the Amazonka environment from the dependencies, right? And that's going to get it. That's going to be our env from before, and then uh, there's also a function in our dependencies that just gives us the current time, right? We're going to go grab that, and it's going to give us the current time because I want to store the file in a time-based sort of path in S3. So I want to say like 2003 slash 10 slash 21 as the path to where I'm going to store the file, just because I want to sort them by dates. And then I'm going to build this S3 config object where from the config, I just grab the bucket and the prefix. The prefix is what's going to go in front of, like, for example, the 2025 part. So this is going to be like, my data slash 2025 slash 10 slash 21, right? Or whatever you want, right? So we'll have that, and then we're close. Hang on. Right. So this is kind of like this is gonna this generate key function here will just assemble all the pieces that we need from this S3 config, the ticker, and the current time to give us a path that's reasonable, right? So it's going to assemble a path that kind of looks like that we want to pass to our uh, to our put object that we kind of remember from before, right? As to where we want to put the data, and then we need to also create a bucket name object, right? So we just pass in like the bucket name out of the config, and that'll give us a bucket name, and then that will be uh, as seen before, right? We can call the upload to S3 by passing in the dependencies, the environment, the bucket name, the object key, and the body. And this is going to ultimately write the file to S3. So at this point, that's kind of it in terms of like writing writing a file to S3, right? Like this was kind of my goal. I wanted to see what this looked like in Haskell, and I think this is what I came up with. Um, um, I can talk about just a little bit more about maybe like application configuration requirements, and then we'll get to see that code running here in a minute, if that's okay.
Cool.
Um, uh, Now I know that there's libraries out there for configuration. Um, I at this point I was a little overwhelmed about like trying to look for libraries to do things, and really it just came down to like I really just want to formulate an object from either the environment or a file, right? And because that's kind of my two situations, right? I'm either coding locally, um, and I want my code to run locally, right? Or I'm out in the cloud and I want to read environment variables from my ECS, definition of my application, right? So those are the two things that I really need for configuration purposes. I came up with this data object, right? And told myself, like, if I had all this information, I would be able to run locally. If I had all this information as like environment variables, I'd be able to run in the in ECS, right? And so I was able to, I just wrote a simple function, load config from file, that given a file path, it would give me an IO of maybe of an app config. And the same goes for the, load config from an environment, right? And so I just attempt to read things from the environment and then get a maybe of an app config. And then I just use this operator between the two to kind of decide which one to use.
Is the operator I truly hate, by the way.
What's that?
Is the one that I very much dislike. In particular, in I/O, is an unlawful implementation. It's just not a doesn't satisfy the alternative laws. But yeah, sorry, I dislike the operator.
Oh, you dislike it? Yeah, okay.
Yeah, very much so. It basically acts as my biggest qualm of it. It suppresses errors.
Yeah.
So if something goes wrong, you get wrong from the last operation.
Oh,
and
I see.
When you troubleshoot, you really wanted to know what happened to the first.
Yeah.
But that is a consequence of the instances, by the way.
No, you really can't do much with alternative as far as. Yeah, there are some which append different error messages, but yeah. But in general, most of them.
Does it talk about a given the feature that uses alternative but for either either stuff instead of not IO, but but for tracking warnings and things like that. So you
it's
retain
useful in
all
other
of
places, yes.
Yeah.
But sure. But yes. Sorry for interjecting, but it's like
no, it's
I
fine.
feel passionate about disliking it.
For me, I wanted it like, so for example, right, if I didn't have a config file or environment variables, I want my application to just die, because it just means that like I haven't configured it correctly. And so when I found it, I was like, oh, this looks like something I could use. So so that's kind of what I want to say about config, right? Like it wasn't too hard to kind of roll your own here if you kind of just did something like this. Let's see what's next. Okay, structuring my project, right? Like this was very nice once I had it working. Like and honestly, like this was kind of maybe my first time building a sort of a Haskell project that wasn't, just a main.hs. And putting these files under source, and then kind of like giving them the right kind of headers that they needed, or sort of like uh, uh, what do I want to say? Giving them the right module name at the top, was was a little bit of a struggle until I figured out like what was kind of really happening. But other than that, like that was, also, right. I tried using Stack to get the project up and running. I kind of ran into some issues that I was like getting annoyed by, and honestly, it's been a whole month since I like looked at Stack. I honestly looked at it for like maybe a couple of hours, and it just said screw it. Moved on to Cabal. Cabal ended up working very nicely on my machine. Uh, you know, I know folks, are very fond of Nix for, maybe getting their projects
Yeah,
up and
that's a
running.
whole another mess of things, though. Yeah.
Yeah, exactly. And so I don't know that I have even the space to run Nix on my machine. So uh, uh, um, Cabal ended up working great, and so um, even my Cabal file like turned out to look, pretty nice. I was kind of impressed by how nicely, you can sort of isolate things, and everything is kind of clear as to what you're doing within the Cabal file to sort of to get an idea of like what the project kind of looks like.
Oh, and you have tests using HSpec Discover.
Yeah.
Great.
So at least I started. I don't know if I had time to talk about tests. Maybe they're not. I was able to test a lot of the pure functions just easily, right? But like things that needed some kind of network, because of Scotty using way or y
Oh,
as a as or it's built on y. Uh, I didn't have time to sort of go through and actually implement some fake HTTP requests and then pass those in the dependencies that you saw in the in the parameter of copy data to S3. So what is okay? So so the quick
sure.
demo. Let's not forget that the most
Yeah.
important part. Um, so here we're going to look at we'll just look at um, um, the health endpoint really quick.
What was your history there? What was showing your history?
Um, Control
Is that,
R.
no, but I mean, like, what program is that?
Um, this is
Because it looks, I use the one called Atwin or something like that, but this looks very different, and I'm just curious. So.
I forget what I'm using here,
Okay,
honestly.
sorry, I don't mean to distract from everything. I just caught my eye. Go for your demo,
Yeah.
your health.
So yeah, so HealthWorks. I'm making this is a server that I have running out on AWS, right? It's deployed
Good thing this talk
onto
wasn't yesterday, huh?
what's that? Yes.
Good thing this
So
talk wasn't yesterday.
no kidding. Um, I was bit by it because I was trying to deploy things on Sunday night, and I
Uh,
was up late, and I was tired, and I was like, did I do something wrong? Because like
oh
all of a
man,
sudden
yeah.
my Terraform would not deploy, and I'm like, what the hell's going on? And so I spent like another 2 hours trying to figure it out, and I was like, okay, screw it. I went to bed mad. And then woke up in the morning and noticed that the world had fallen apart.
Yeah.
Um, okay, so now let's look at curl the post one. So we're gonna post. So this doesn't return anything and so we're going to say that we're going to download Apple, for today, and we're going to post, and we're going to see some of the curl verbosity here. Okay, and there's our 200, and then if we look at our S S3 AWS CLI command here. So you can sort of see here, like on October, we'll just get a listing here, right? I ran these days, right? Even though it's the 21st today, right? This kind of shows up as the 22nd
UTC.
because of UTC's things. So on the 22nd, there's our Apple data downloaded, and it's that large,
Cool.
and it's in a bucket, right?
I would suggest that maybe you return that URL, the S3 URL from your download request.
Return the
S3, that financial data 2025 1022. So like basically the response contains like here's where I put it on S3, so you can like
okay,
basically
that's a good point.
have
Yes.
access to that exact one for that request. Because if you're like running a service and it's like generating a whole bunch of them all the time, you're like, wait,
Yeah.
was the one I just ran this one or was it that one? Like, does it matter exactly which one? So
yeah, good point. So like return like this piece, or maybe even the whole path.
I think the whole
to the
thing,
file,
the whole S3.
to the file. Yeah, good point.
Yeah.
Okay, so let me just go back to Patat. And where are we?
It's a demo. There it is.
Yeah. So okay. So some takeaways. The Haskell ecosystem, I was like very intimidated by it, honestly, initially, and it was a lot better than I expected. I was actually very pleased by it. I would definitely work on it again, work or keep working on it to learn more of it. But it was nice. Um, the hackage library search was like, I think it was on par with like the Rust crates.io. You know, I it's it wasn't too bad once I realized where I should fixate my eyes on to like look for the things that I needed to look at, right? Because there's a lot of information when some of these things return, and like I think the simpler the better might be, but like, and even when you click on a library, right, there's so much text in there.
Yeah,
But
all
like,
the modules, and you're just like, where is the entry point to this thing? Like, which of these
yeah,
things should I be importing and using? Yeah.
yeah,
Yeah.
um, uh, right. The operators are key, and they take a little bit of work, a little bit of time to get used to, but they're really nice. I kind of wish, you know, I could use them more often in my daily work.
Cool. Yeah.
Uh, you know, deploying the Haskell or building the Haskell Docker image that I eventually deployed to ECS, right, is here. Let me stop sharing. Actually, let me share something different. Let me share my browser. So okay, now you see my entire screen, right?
Yes.
Okay.
Including
So
this call.
um, oh, sorry. Let me. Here. So you can see some of the build times.
Mm-hmm.
Enter picture. Some of the build times for the Docker image, right? Um, about 11 minutes, and
Mm-hmm.
this one for some reason took 16, 11. And so I think this is about as long as it takes for us to build Rust Docker images at work as well. You know, And so, and honestly, like I'm not caching anything. This is like straight just build, and then at the end it does push to an ECR uh, container registry on in AWS. So it includes that amount of time as well. Um, the repo also contains some the Terraform that you need to. I didn't want to talk about that, but
Yeah.
if you know, maybe we could do a tandem like uh, talk with the Boulder DevOps team or something. uh, but I think most of what you'll need in there, if you're interested in deploying something like this, is all there. Um, uh, uh, that you can go look at. Um, okay. What else? Oh, so future ideas. So I don't know if this is something that we want to, continue or you know, uh, but like if I had the energy and if I had, if you guys, welcome me back, I would do things like maybe improve tests, like just testing in general would be good to like just talk about. Um, improve logging, right? Because maybe folks want to like log to, like Honeycomb or Datadog or something. And how do you get good logging out of your application? Um, so instead of like making a request to download data, maybe we write a scheduler and we tell the scheduler when to go pull some of this data for us, right? And then just deploy that and have our system just kind of do its own thing in the background, right? And we can just pick up the data whenever we want or go query it, in some way. Security, right? Like I'm not doing any of that. It would be great to like, I'm gonna go tear down what we have right now so that nobody DDoSes my stuff. um, but like, just how does that look? What does that look like? How can I, either do like API sort of maybe like um, guarding, the number of requests that you can make per minute or whatever. um, all kinds of stuff that we can do here. Authentication, authorization. Uh, we could do analysis on the data, right? Like now that we have some set of files, right? Or even better, like what if you wanted to? What if you had like a portfolio? What if you told me like, here's my portfolio and it's these 10 tickers, right? We pull all that data, right? You give it to the service, it pulls all that data for you. Now you have all this data sitting there. And now we want to write some Haskell to do some analysis on that data for some, to give you back some kind of, information about or compute some kind of metric on your set of tickers, Um, we can turn this into like a distributed system, like, where we'll have a leader, right? That just asks the workers to go do maybe the download or the analysis or whatever else we want.
Mhm.
I've been interested in like doing this kind of stuff, in various languages just to kind of see what the ergonomics are. Uh, you know, given a ticker, instead of downloading like the actual financial data, we can look at what it looks like to download maybe news snippets. Uh, this should be news snippets and do some sentiment analysis, right? What does like natural language processing look like in Haskell? Can we do it? And can what does that look like? Um, uh, you know, it this is deployed currently to ECS. What does it look like if we deploy it to Kubernetes? I know that's not necessarily part of the spirit of this meetup, but it could be useful to some folks who just want to see what this looks like. Questions?
Okay, I've got some stuff.
Yeah.
So one, this was fantastic. I feel like
you.
I got a lot out of it. And I imagine, I mean, we're not like a huge group or anything, but I mean, there's at least two of us are professional Haskell programmers. And so, coming at this as like a new Haskell programmer and being like, here's this thing I created is, I feel like kind of a brave move. So, no, I thought it was great. So, I think your future directions sound great. If you see something in particular that you want to focus on, to like explore and do more of this stuff, I would love to hear more about how it goes for you. I had a couple things. If you go back to slide 38,
Okay.
I think that's where. I know. One of my questions was, do you know about Hugel?
Hugel.
Google with an H.
I've heard of it. I didn't use it for this project.
Okay, because the library. So this is something I always want in other languages, like including Rust. Whereas like you could type like the name of a function or in any library basically, or a function type, and it will tell you things that have that type, or even similar types. It's like not necessarily exactly that type. It can really help with the library discovery thing a lot. You'd be like, oh, I want to do something like this, and even if you just click through and look at the source and be like, oh, I'll just implement that function, whatever.
Yeah.
But you can it can be really helpful for discovery that way. So on this slide, if you'll move my face out of the way of the code. Two things I noticed here. So one, I had this question. You have this dependencies type, which I think is good.
Mm-hmm.
Where did you get that idea from? Where did that?
So so looking around in terms of like testing, right? Because that's kind of where I was heading with it. Like I want to be able to do like be able to like mock some functions that maybe don't go out to Yahoo Finance, right, to return a file, right? I can have a file check, maybe a test file that I check into source code, and that would be the file that function sort of returns, and so on. So like, yeah, just mocking for like mocking purposes.
Yeah.
I saw some folks, talking about like, well, this is how how we would do testing is like, well, if the function you're writing and you want to test does some kind of IO work, right, then you probably want to inject that function that that does that work.
Yeah. So this is an approach that I use a lot, and I know a few other people who do at least. And it's at least we tend to call it the capabilities pattern or model or whatever.
Okay.
And it's a little bit different, and I think you get a lot out of it if you make this one change. And because it is helpful for testing and mocking that way. But I think even beyond that, one of the things that's nice about it is like, so basically, if you make dependencies and instead of just working on IO, like in all the functions that are in there, if you parameterize them on just an F, so in the type declaration, right, you would say like data dependencies F, and then replace all the IOs with F. And then when you define a value of type dependencies, you can define a dependencies IO, which would be your real one, right? And then you could define a dependencies either or something that is like your mock one. And so it doesn't even have IO. You can like basically like show that there's no IO happening there. And then the cool thing is this function that takes dependencies would only have like a monad constraint on the F. And so instead of, it will return F of either, blah, blah, blah. So you're basically saying like, I don't do anything with IO. Like this is a pure function, right? You give me a set of functions, however you implemented them to accomplish these specific things. And those are the only things I can do with IO. Like I don't have any other access to IO. And so it really gives you that ability to write a lot more code that's pure.
Okay.
Outside of having any IO.
So basically you replace the IO with F, right?
Yeah.
So basically you're writing polymorphic function, polymorphic the monad you're using, which is pretty cool. So by switching
it's something I
monads,
feel like I often have to convince Haskellers of doing things this way. And so it's cool to see you as your first program are doing it. And with just like a couple tweaks to the types, it becomes like a really powerful technique for writing pure code.
Cool. I might ping you about that so I can
Yeah, I'd be happy to.
make some
So,
modifications.
so there is a different way to go about this, and this is probably something that I do a lot. If you think about, so like IO has a name in Haskell called synbin,
Hmm.
right? Because it can do anything,
Yeah.
right? And you kind of don't know, copy URL to S3. What the hell does it do? If you trust the name, you trust the name, right? But does it can do anything, right?
It can do anything. Yeah,
Um,
exactly.
So so the idea is basically but what it really does, it's basically does AWS stuff. It
Yeah.
doesn't do any HTTP stuff actually, this guy, right?
Hmm.
The other one does the HTTP stuff, the other one that you were doing, but didn't do like AWS stuff. So if you can somehow express this in types and have types which allow you to only do HTTP stuff or
Yeah.
only do
Right.
AWS stuff.
Like, so split your dependencies into HTTP ops and AWS ops or whatever it is. And so then you can have this one only take AWS ops, right? And you know exactly which functions it's going to call. Yeah. I think but I think this is, a really good start with that. And it's something I don't expect to see in someone new to Haskell for sure, because I don't see it in experienced Haskellers code. And I think it's a great approach. And the other thing really quick here is what you call case fetch result. That is traverse, which is a very common function that shows up all the time, and you can see how to translate that into traverse, basically to simplify that code, because it's something that it's kind of like the F map, like that map operator you did. But what it does is that if the function you're calling returns in some monad, it effectively pulls that to the outside of the type, if that makes sense, right? So if you have an A to FB, it will turn your either whatever A into a F of either whatever B. It's not easy to just describe it, but
Sure.
anyway, I think another thing to look into is the traverse thing.
On which line? Sorry.
Just the whole case statement, the last like 10 lines of the thing.
Okay, this guy. Okay.
That whole thing. Yeah. So basically, all you write is the handler for write, and then like you don't have to do any like left. Just as a magical part because it's it's polymorphic over any applicative functor there. And yeah, so it just simplifies that a bit, and it's a very common pattern. So you end up writing code that looks more like what you did for with the F map, with that bracket $sign operator than pattern than a specific pattern matching everywhere. But again, just another thing to look into. But but I like this, and I would definitely hear more about future explorations in this area. I think this is really cool.
Okay.
Yep. Definitely. If you want to continue this, it'll be very interesting to listen where you want to go.
Sure.
Yeah. Thanks so much, Nick. Really appreciate it.
Thank you, guys. Thank you, Joseph, for showing up.
Well, of course. So I didn't contribute very much, but I enjoyed it. And I look forward to seeing what you come up with next.
All right. Thank you so much.
Great demonstration. I learned a lot.
All right. See you guys next time.
All right. Yeah. Thanks again, Nick. Okay.
Yep.
See y'all.
See you all.
Thank you. Bye.